The sky over our head is vast, radiant, mystic, with fluffy white clouds at most times. But I often wonder why the sky has different colors at different times, even though most of the time it is blue. Sunlight is made up of the 7 colors: violet, indigo, blue, green, yellow, orange, and red. Then why the preference for blue? Let us have a look at the phenomenon in slightly greater depth. The first term we want to introduce is scattering. Scattering is a phenomenon by which the unidirectional nature of rays of sunlight is changed. The rays are absorbed by tiny particles and re-emitted in random directions, thus scattering the light. The type of scattering, however, depends on the size of the scattering particle. If the size of the particle scattering the light is much smaller than the wavelength of incident light, then there is preferential scattering of the shorter wavelengths like violet and blue. In the upper atmosphere, the size of the dust particles is very small, as bigger and heavier particles would fall nearer to the surface of the earth. These tiny particles, along with gases present in the atmosphere, preferentially scatter the violet and blue colors of sunlight. Rayleigh showed that for this kind of scattering, the scattering coefficient depends inversely on the 4th power of the wavelength of incident light. So, the colors having shorter wavelength are scattered more, while longer wavelengths like red and orange are scattered very little. The color of the sky at any time depends on the amount of scattering and the angle of the sun with respect to the viewer. The amount of scattering and the type of scattering, whether Rayleigh or Mie scattering, again depends on the amount of dust particles, water vapor, or fog in the air. As mentioned earlier, if the scattering particle is much smaller than the wavelength of incident light, then there is preferential scattering of the shorter wavelengths, while if the scattering particle is larger than the wavelength of incident light, then there is non-preferential scattering of light. In such a scenario, called Mie scattering, all wavelengths are equally scattered. When the sun is at the horizon, that is, at sunrise and sunset, sunlight travels through a large section of the atmosphere and thus has enough opportunity for the violet and blue light to be scattered away, particularly in the upper atmosphere, leaving only the yellow, orange, and red to enter the observer's eye. The sun thus looks that typical red-orange color at sunrise and sunset. We also see sometimes a purplish color sky. This is partially due to the optical illusion of the pink wavelengths lighting up the base of the cloud. This is principally due to the low angle of the sun's rays, and these pink clouds, when superimposed on a dark blue sky, can make the sky appear a deep purple. At noon, the sunlight has to travel a relatively shorter distance to reach the observer. The opportunity for scattering is therefore lower, but there is scattering. While looking up, an observer would see orange-red color along with a bit of blue-violet in a background of blue-violet. Thus, all the colors of the spectrum actually enter the eye, making the sun appear white. So far, we have been focusing on scattering by particles smaller than the wavelength of light. What happens when the scattering particle is bigger than the wavelength of incident light? This is the case of Mie scattering. In Mie scattering, there is non-preferential scattering of light. That is, all wavelengths of light are equally scattered. This is what happens in clouds. The particles that make up clouds are much bigger than the wavelength of incident light. Thus, all the incident white light is equally scattered, making clouds appear white. Before rain, as the size and concentration of the hydrometeors increases, less and less sunlight penetrates the cloud. We perceive these clouds as dark clouds in varying shades of gray. Clouds appear dark when they are thicker and denser than normal clouds of a day of mild weather. As a cloud gathers more water droplets and ice crystals, it becomes thicker and allows less light to pass through it. Have you heard of the saying, "Orange sky at night, sailors take delight. Orange sky in the morning, sailors take their warning"? At sunset, an orange sky means there's a lot of dust and moisture in the air, probably thrown up by wind somewhere. It is normally expected that the next day would be calm and therefore good weather. A red sunrise can mean that a high-pressure system, good weather in other words, has already passed, thus indicating that a storm system, low pressure, may be moving to the east. A morning sky that is a deep fiery red can indicate that there is high water content in the atmosphere and therefore an impending storm.